This is vector part 2. It is given that the line L1 has Cartesian equation and the line L2 passes through the point 1, 4, 6 and it's parallel to the vector I minus 2j minus 2k. Determine the vector equation of the line L1 and L2. So L1 has the Cartesian equation of x minus 1 over 3, y plus 4 over 2, and z plus 1 over 1. To convert from the Cartesian equation to the vector equation, we have to see the initial points and the vector direction of the line. The initial point can be taken from these numbers. So this is r equals to, the initial points are 1, minus 4, and minus 1. Plus parameter lambda times the direction vector. The direction vector is taken from the denominator 3, 2, and 1. 3, 2, and 1. So this is the equation of line L1. How about L2? For L2, the line passes through point 146, so we can use this point as the initial point, 146, plus the other parameter times the direction vector of the line. The line is parallel to the vector 1 minus 2 minus 2. So we can use this vector as the direction vector of the line L2. So 1, negative 2, and negative 2. So these are the equations of the line L1 and L2. I show that the two lines intersect and find the coordinate of their common point. So from these two equations, we have to construct the coordinate of the intersection point. So from the L1, the coordinates are 1 plus 3 lambda, so we can combine it, minus 4 plus 2 lambda, and then negative 1 plus lambda. And from the L1, L2, this is 1 plus mu, 4 minus 2 mu, and 6 minus 2 mu. Now, to find the intersection point, so we have to make the coordinates the same. So that means 1 plus 3 lambda minus 4 plus 2 lambda negative 1 plus lambda should be equal to 1 plus mu, 4 minus 2 mu, and 6 minus 2 mu. Now we have to solve the simultaneous equation containing the lambda and mu from these coordinates. So I can use the second one and the third one. So from the second one, I have minus 4 plus 2 lambda equals to 4 minus 2 mu. And from the third one, I have negative 1 plus lambda equals to 6 minus 2 mu. And then I can just do elimination, I minus, so I can cancel the mu. So this is equals to negative 2, negative 4 minus negative 1 is negative 3. And then 2 lambda minus lambda is plus lambda. So from here, lambda is equals to 1. For mu, I will use this one. So negative 1 plus lambda, lambda is 1. equals to 6 minus 2 mu. So mu is equals to 3. Now, to check if the lines are intersect or not, we have to substitute the mu and the lambda values to the first expression. So we check it for the left 1 plus 3 mu is 3 times 1, so equals to 4. And for the right 1 plus mu is 3 equals to 4. So they are the same. Since they are the same, so the line is intersect. So the lines intersect. And what is the point of intersection? So we can just replace the values of lambda or the mu to one of them. I will use lambda, yeah. So the point of intersection is 1 plus 3 times 1, negative 4 plus 2 times 1, and negative 1 plus 1. So equals to 4 minus 2 and 0. So this is the intersection point. Therefore, I find the correct to the nearest degree, 0.1 degree, the acute angle between L1 and L2. So for this, I can use product rule to find the angle. So cos theta is factor A dot factor B. In this case, the factor A and the factor B will be represented by the direction factor of the lines. So it's 3, 2, 1, dot 1, negative 2, negative 2. Yeah, because the direction of the line will become the factor. So we can find the angle between them. So using the direction factor. So divided by the magnitude of 3, 2, and 1, 9 plus 4 plus 1. It's root of 14. Root of 14. And then this 1 plus 4 plus 4, so it's 3. So that means cos theta will be equals to 3 minus 4 minus 2 over 3 root 14. So this is equals to minus 3 over 3 root 14. In this case, the angle should be acute. So we can ignore the negative by put the absolute value. So we find the positive value of cos theta. So the theta will be equals to cos inverse 1 over root 14 equals to 74.5 degrees. That's for number 1. Number 2, with respect to origin O, the position, the point A, B, C, D have position factors given by the L1, L2, OA, OB, OC, and OD. Calculate the acute angle between AB and CD. So that means we have to find the factor of AB. Factor AB is B minus A. So 5, negative 2, negative 2, minus 4, 0, 1. So equals to 1 minus 2 minus 3. And CD is D minus C. So D is minus 1, 0 minus 4, minus C, 1, 1, 0. So equals to -2, -1, -4. Acute angle, so we can find the cos theta equals to absolute of 1, -2, -3, dot -2, -1, -4 over the magnitude is 1 plus 4 plus 9. 14, square root of 14. 4 plus 1, 5, 20 plus 16, so 21. So that means this will be equals to -2 plus 2 plus 12 over root 14 root 21. So this will be equals to 12 over root 14 root 21. So this is cos theta. So the theta is 12 divided by root 14 and root 21. And then cos inverse. So 45.6 degrees. I prove that the lines AD and CD intersect. So we can find the equation of the line AD. So this is A, this is B. So the equation of AD is the initial point. I can use point A, 4, 0, 1, plus lambda times the direction vector of AB. So 1, -2, -3. That's AB. How about the CD? CD, so the vector equation will be the initial point. I choose C, 1, 1, 0, plus mu times the direction of CD, -2, -1, -4. So in this case, I can ignore the negative here. So 1, 1, 0, plus mu 2, 1, 4. And then find the coordinate. So the coordinate 4 plus lambda minus 2 lambda and 1 minus 3 lambda. And from the LCD, line CD, I have 1 plus 2 mu, 1 plus mu, and 4 mu. And then to prove that they are intersect, we have to make sure that all the components have the same value. So I can construct the equation of the first one and the third one of each line. Yeah? So I can construct 4 plus lambda on the line AB equal to the first row 1 plus 2 mu of the line CD. And then I will take the third row. The third row will be 1 minus 3 lambda from the AB. And then from CD is equal to 4 mu. And then I do elimination. So I multiply the first one by 2. Become 8 plus 2 lambda equals to 2 plus 4 mu. And the second one, 1 minus 3 mu lambda equals to 4 mu. And then I minus. So I can cancel the mu. So this is equals to 2. 8 minus 1 is 7. And 2 minus -3 is 5 lambda. So lambda here is equals to -1. If lambda is -1, so I can find mu. So I put it here, 1 minus 3 times -1 equals to 4 mu. So 1 plus 3 equals to 4 mu. So 4 equals to 4 mu and mu equals to 1. And then since we are equalized the first and the third row, so we check on the second row. So on the second row, I will have -2 lambda for the second row, -2 lambda, so equals to -2 times -1 equals to 2. And from the CD, the second row will be 1 plus mu equals to 1 plus 1 equals to 2. So they are the same. So that means they are imperfect because all the components the same. The third one, the point P has a position factor 1, 5, 6. Show that the perpendicular distance from P to the line AB is equal to √3. So there is a point P of 1, 5, 6. I wrote them in the coordinates 1, 5, 6. From AB, find that the perpendicular distance from P to AB is equal to √3. So this is the perpendicular distance. So I can use scalar product to find the perpendicular distance. So in this case, I have to find factor AP. So AP is equals to, the coordinate of A is 4, 0, 1. So AP will be P minus A. So 1 minus 4 is -3. 5 minus 0 is 5. 6 minus 1 is 5. So this is factor AP. And then we need the magnitude of AP. So equals to root of -3 square plus 5 square plus 5 square. So root of 50 plus 9, so root of 59. And then to find the projection, so this is AP cos theta. So AP cos theta equals to AP dot the line AB over magnitude of the line AB. So AP is -355 dot the line AB is represented by the direction vector of AB. So 1, -2, -3 divided by the magnitude of AB. So root of 1 plus 4, 5, 5 plus 9, 14. So this is equals to -3 minus 10 minus 15 over root of 14. So this is equals to -28 over root of 14. Since the projection is a scalar, so we don't have the negative, so we absolute it. So it's 28 over 14, root of 14. That's the projection. Now, to find the perpendicular, we can do the Pythagoras. This is the length of AP, which is root of 59. And the projection is 28 over root of 14. So that means the P, I put it N, yeah. So Pn should be square root of 59 square minus 28 over 14 square. So the result is 59 minus 28. This is root, yeah? Square root over square root of 14 and then square. And then it's equals to root 3. So shown. Move on to number 3. The point A and B has position vector relative to the origin O given by OA and OB. The line L has vector equation. So I write the vector equation. This is 1 minus 2t, 5 plus t, and 2 minus t. Or I can rewrite as R equals to 152 plus t -2, 1, -1. I can rewrite as that. Show that L does not intersect the line passing through A and B. So again, we have to find the equation of AB. So AB has a vector position B minus A. So this is 213 minus 123. So equals to 1, -1, 0. So this is direction vector of AB. So the line equation of AB is equals to the initial point. I will choose A, 1, 2, 3, plus lambda times 1 minus 1, 0, the direction vector of AB. So from here, I can find the coordinates of AB, 1 plus lambda, 2 minus lambda, and 3. To find the line L intersect or not to the line AB, so we have to check are all the components of the rows has the same value or not. So we have to check it with the line L. So the coordinate of AB, 1 plus lambda, 2 minus lambda, and 3 should be equal to 1 minus 2t, 5 plus t, and 2 minus t. So I will use the third row to find t. 3 equals to 2 minus t, so t equals to -1. And then I will choose the second row to find the lambda. 2 minus lambda equals to 5 plus t, so 5 minus 1. So that means from here, I will have 2 minus lambda equals to 4, so lambda is -2. Now, check it to the first row. For the first row, I will have 1 plus lambda equals to 1 minus 2 equals to -1. And from the line L1, the first row, will be 1 minus 2t equals to 1 minus 2 times -1. So equals to 2. 3, yeah? So that means, since they are not the same, so they are not intersect. All right? The point P lies on L, and it's such that angle PAB is equal to 60. So this is the line L, and there is a point P. So angle PAB is equal to 60 degrees. So I have A and B somewhere here. This is A, this is B. Okay, I move A. The A, I move here. A, B. So the angle PAB, so PAB, this angle, it says equals to 60 degree. Okay, this is obtuse here. So this is only sketch, but I will try to fix it so it can be seen as 60 degree. But actually, the sketch is not really matters. So this is the theta should be 60 equals to 60 degree. Given that the position vector of P is the vector equation of the line, because it lies on the line L1, on the line L. Show that it will become 3t squared plus 7t plus 2 equals to 0, and hence find the only possible position vector P. Okay, so that means in here, we know that angle is 60 degree, so we know the coordinate of the P is 1 minus 2t, 5 plus t, and 2 minus t. So to find the angle using the scalar product, we have to find the vector AP and AB. So find AP first. So P minus A, 1 minus 2t, 5 minus plus t, and 2 minus t. Minus A. A is 1, 2, 3. So equals to minus 2t. 5 minus 2 is 3 plus t. And then 2 minus 3 is minus 1 minus t. So we will have AP dot AB over magnitude AP and magnitude AB should be equals to cos theta. So from here, we can find AP minus 2t, 3 plus t, minus 1 minus t, and then dot AB, AB is 1, negative 1, 0, over, this is square root of 2, this is square root of minus 2t squared plus 3 plus t squared plus negative 1 minus t squared equals to cos 60. So this is half. So we can simplify this. So 2t, negative 2t, minus 3 minus t plus 0 over the square root of, expand this one, so 4t squared plus 9 plus 6t plus t squared plus 1 plus 2t plus t squared. Root 2 equals to half. And then I can simplify first here. Negative 3t minus 3 root of 4t squared plus t squared, 5t squared. So 6t squared. And then 6t plus 2t plus 8t. And then 9 plus 1 plus 10. Root of 2 equals to half. And then cross multiply. Negative 60 minus 6 equals to root of, I can multiply by 2 here. So 12t squared plus 16t plus 20. And then to remove the root, I have to square both sides. So it's become 36t squared plus 72t plus 36 equals to 12t squared plus 16t plus 20. And then we simplify it, 24t squared plus 72 minus 16 is 56t plus 16 equals to 0. And then we divide by 8, 3t squared plus 7t plus 2 equals to 0. And then, so this is equal to this. So this is shown. And then we have to find the only possible position. So we have to solve it. So solve this, factorize t. So this is plus 2 and plus 1. So t is negative 1 over 3, or t equals to negative 2. So in this case, we can use the values of t. So from these two values here, if t equals to negative 1 over 3, we have to consider one thing, that the angle is 60 degrees. So it's an acute angle. So that means factor A dot factor B should be a positive to have an acute angle. So we have to check from this. Negative 3, negative 1 over 3, minus 3. So we will have this equals to negative 2. So this will be an obtuse angle. For t equals to negative 2, I have negative 3 times negative 2 minus 3. So 6 minus 3 is 3, positive. So this will be acute. So the t of negative 2 is taken. So that means the position factor of P will be negative 2. P is, what is P? P is 1 minus 2t. Yeah. So 1 minus 2 times t, negative 2. 5 minus 2 and 2 minus negative 2. So equals to 5, 3, 4. So this is the answer.